For 76 years, Pluto proudly held its place as the ninth planet of our solar system. Then, almost overnight, it was stripped of that title. Textbooks were rewritten, scientists debated, and people around the world were left asking, how could something we all learned in school suddenly be wrong? Pluto went from being a beloved planet to a so-called dwarf planet, a cosmic outcast drifting at the edge of the sun's reach. But what if the real story isn't about Pluto losing its status? What if it's about how our understanding of the universe has evolved? If you look up into the night sky, you'll never spot Pluto with your naked eye. It's far too small, too dim, and too distant, a tiny icy wanderer hidden at the edge of our solar system. Yet for decades, this little world captured the hearts of scientists and the public alike. To understand why Pluto's story is so powerful, we first need to understand what kind of place it really is. Pluto lies in a region known as the Kuiper Belt, a vast ring of icy bodies, comets, and dwarf planets that circles the sun beyond Neptune. You can think of the Kuiper Belt as the solar system's deep freezer, a region that has remained almost untouched since the early days of our cosmic neighborhood. Everything out there, including Pluto, is like a preserved fossil, holding clues about what our solar system looked like 4.5 billion years ago. Now, imagine the sun as a glowing campfire. Earth sits close enough to feel its warmth, but Pluto is like a snowflake drifting on the outer edge of that fire's faint glow. About 3.7 billion miles, 5.9 billion kilometers away on average. Because of that incredible distance, sunlight takes 5.5 hours just to reach it. By the time light arrives, it's about 2,600 times dimmer than what we see on Earth. So, even though it's daytime on Pluto, the sun would look more like a bright star in a pitch-black sky. Temperatures there are unimaginably cold, around 375 degree, 225 degree. That's so cold that nitrogen, which makes up most of the air we breathe, freezes solid on the surface. The ground isn't made of rock or soil like Earth's. Instead, it's a frozen mixture of nitrogen, methane, carbon monoxide, and water ice. The result? A world glittering with plains of ice, mountains made of frozen water, and even hazy layers of atmosphere that shimmer faintly in the darkness. But perhaps the most surprising fact is just how small Pluto really is. For decades, astronomers assumed it was nearly as large as Earth, until better instruments revealed the truth. Pluto is only about 1,473 miles, 2,377 kilometers across, roughly two-thirds the diameter of our moon and just 1/6 of its mass. You could fit 6 Plutos across the width of the United States, and it still wouldn't fill it entirely. In fact, if Earth were the size of a basketball, Pluto would be smaller than a golf ball. Still, what Pluto lacks in size, it makes up for in personality. It has a surprisingly dynamic system of 5 moons: Charon, Styx, Nix, Kerberos, and Hydra. Charon, the largest, is so big compared to Pluto that the two actually orbit each other around a shared center of gravity located in the space between them. No other planet-moon pair in the solar system behaves quite like this. It's almost as if Pluto and Charon are cosmic dance partners, forever locked in a graceful orbit, each tugging gently on the other. Pluto's orbit is another piece of its strange charm. Unlike the near-perfect circles of most planets, Pluto travels in a highly elliptical and tilted path. Sometimes it swings closer to the Sun than Neptune, and other times it drifts nearly 1 billion miles farther away. It's also tilted by 17 degrees, meaning it moves on a different plane than the other planets, like an outlier marching to its own beat. And here's the astonishing part. 1 year on Pluto, one complete orbit around the Sun, lasts 248 Earth years. Since its discovery in 1930, Pluto hasn't even made it halfway through a single orbit. Now, despite its distance, Pluto isn't lifeless or dull. Thanks to NASA's New Horizons spacecraft, which flew past in 2015, we now know that Pluto is incredibly active. Its surface isn't static. There are mountains of ice taller than the Rockies, smooth plains that look like frozen seas, and evidence that glaciers made of nitrogen slowly flow across its surface. Some scientists even believe that a liquid ocean might still exist beneath its frozen crust, however kept warm by the heat trapped inside its rocky core. And when sunlight hits Pluto's thin atmosphere, made mostly of nitrogen, with traces of methane, something amazing happens. Ultraviolet radiation breaks down the methane molecules, triggering chemical reactions that create tholins, reddish-brown organic compounds that gently fall back to the surface like snow. These tholins give Pluto its unique reddish hue, a soft alien color that paints it as more than just a frozen gray rock. So, when we call Pluto a tiny dot, we are technically right, but also profoundly wrong. Yes, it's small and distant, but it's not simple or insignificant. Pluto is a complex, dynamic, and evolving world, one that tells us more about how planets form than almost any other body in the solar system. It may be smaller than Earth's moon, but its story is enormous, a story that stretches from the dawn of the solar system to the frontiers of modern space exploration. Pluto reminds us that size doesn't define importance, and even the smallest world at the edge of the sun's light can hold some of the biggest mysteries in science. For centuries, astronomers believed the solar system ended with Neptune. It was the farthest known planet, discovered in 1846, and its presence seemed to complete the elegant pattern of worlds orbiting our sun. But as scientists studied the paths of Uranus and Neptune more closely, something didn't quite add up. Their orbits weren't perfectly aligned with predictions. They wobbled ever so slightly, as if an invisible force were tugging on them from the darkness beyond. This unexplained disturbance gave birth to one of astronomy's greatest mysteries, the hunt for a hidden world known as Planet X. The idea of Planet X captivated the imagination of Percival Lowell, a wealthy American astronomer and visionary. In the early 1900s, Lowell was already famous and controversial for claiming to see canals on Mars, which he believed were built by an intelligent civilization. Though his Martian canals would later be proven false, Lowell's passion for the unknown drove him to look even farther out, beyond Neptune, for a mysterious ninth planet that could explain the strange motions of its neighbors. In 1905, Lowell began an ambitious search from his observatory in Flagstaff, Arizona, which would later bear his name. The Lowell Observatory. Armed with the best photographic telescopes of his time, he and his team began capturing long-exposure images of the night sky, one small section at a time. The process was painstaking. They photographed the same areas of sky weeks apart, hoping to find a tiny moving dot, a planet too faint to see with the naked eye. Each image contained thousands of stars, and detecting even the slightest shift required exceptional patience. Lowell performed complex mathematical calculations, predicting where Planet X should appear based on the gravitational pull it supposedly exerted. For more than a decade, Lowell searched the heavens relentlessly, but Planet X never appeared. He died in 1916 without finding the world he had devoted his life to. For years afterward, his observatory was locked in legal disputes, and the search came to a halt. Yet in the dusty archives of his observatory, Lowell's calculations and photographic plates remained preserved, silent clues waiting for the right person to look again. That person would be a young, self-taught astronomer named Clyde Tombaugh. Born on a Kansas farm in 1906, Tombaugh grew up fascinated by the night sky. Without money for college or professional equipment, he built his own telescopes from old farm machinery, car parts, and scraps of metal. His homemade telescopes were so precise that he could sketch detailed observations of Mars and Jupiter. Impressed by his skill, the Lowell Observatory offered him a job in 1929 to resume the search for Planet X that had begun 2 decades earlier. Tombaugh's assignment was grueling. He was to systematically photograph the sky with a state-of-the-art camera, then use a special device called a blink comparator to compare pairs of photographic plates. The blink comparator rapidly switched between 2 images of the same star field, taken days or weeks apart. If any small dot of light appeared to move between frames, it could be a planet or an asteroid. This meant staring through the comparator for hours on end, manually checking every star on every plate. It was a job that required a sharp eye, extraordinary focus, and enormous patience. After nearly a year of work, on February 18, 1930, Tombaugh noticed something unusual. On 2 photographic plates taken 6 days apart, a tiny point of light had shifted slightly against the fixed backdrop of stars. He double-checked and then checked again. The movement was real. It was not a star. It was an object orbiting the sun far beyond Neptune. After all the years of searching, the mysterious Planet X had finally been found. though it turned out to be far smaller than anyone had expected. The announcement of the discovery sent shockwaves through the scientific community and the world. Headlines proclaimed, "New planet found beyond Neptune," and schools eagerly added a ninth planet to their lessons. At the Lowell Observatory, the team debated what to name this new world. Suggestions poured in from across the globe. Then a letter arrived from an 11-year-old girl in England named Venetia Burney, who proposed the name Pluto after the Roman god of the underworld, ruler of the dark and distant realm below the earth. The name fit perfectly, short, mysterious, and symbolically tied to the hidden, icy depths of space. On March 24, 1930, the name Pluto was officially adopted. Astronomers later noticed that the first two letters, P and L, were also Percival Lowell's initials, a fitting tribute to the man whose dream had sparked the search. Although Lowell never lived to see it, Pluto's discovery fulfilled his quest for a world beyond Neptune. At the time, astronomers believed they had found a planet nearly as massive as Earth. Pluto's distance and faintness made it difficult to study, and early estimates dramatically overestimated its size. It would take decades before scientists learned the truth. Pluto was far smaller, even smaller than Earth's moon. But in 1930, none of that mattered. For the first time in modern history, humanity had extended its reach beyond Neptune. The discovery of Pluto marked more than just the addition of another planet. It represented a triumph of human curiosity and persistence. A farm boy with a homemade telescope had confirmed the existence of a world no one had ever seen. Newspapers around the world celebrated him as a hero, and the tiny dot he found became a global symbol of discovery. For generations of schoolchildren, the solar system would have 9 planets, Mercury to Pluto, with that small, frozen world standing proudly at the edge of everything we knew. Pluto's discovery wasn't just a scientific achievement. It was a story of imagination, hope, and the human desire to explore. It began with a mystery in the math, fueled by one astronomer's dream, and ended with another's determination to find what others could not see. And while we would later learn that Pluto didn't fit the classical definition of a planet, the moment of its discovery remains one of the most inspiring chapters in the history of astronomy. When Clyde Tombaugh discovered Pluto in 1930, the scientific world erupted with excitement. It had been nearly a century since the discovery of Neptune, and humanity's vision of the cosmos had just expanded once again. The mysterious Planet X that astronomers had been searching for was finally found, or so they thought. The newspapers of the time carried triumphant headlines, "Ninth planet found beyond Neptune." School teachers proudly added Pluto to classroom charts of the solar system. The new world, small and faint though it was, instantly became a symbol of discovery, of human perseverance, and of our never-ending curiosity about what lies beyond. For the general public, the idea of a 9th planet had a kind of poetic symmetry. There were now 9 planets, 9 worlds circling the sun, a perfect cosmic order. The name Pluto, suggested by 11-year-old Venetia Burney, resonated deeply with people. It evoked mystery, darkness, and distance, a fitting name for a world on the edge of sunlight. Even the abbreviation PL seemed a tribute to Percival Lowell, whose passion and persistence had made the search possible. Everything about the discovery seemed to click into place, as if Pluto had always been waiting for us to find it. In the early 1930s, astronomers had limited technology to study Pluto. They couldn't measure its size directly. All they could see was a faint speck of light through telescopes. But because it was so far away, and because it had been predicted by Lowell's calculations, many assumed it was a large, heavy planet. Early estimates placed Pluto's mass as similar to Earth's, perhaps even greater. For a time, scientists believed this was the massive object responsible for tugging on Neptune and Uranus, solving a decades-old mystery. This idea made Pluto an instant celebrity among the planets. It wasn't just the newest addition, it was the most mysterious. Textbooks described it as a frozen giant, shrouded in darkness, orbiting on the frontier of the solar system. To a generation still reeling from the speed of scientific progress, the discovery of galaxies, the theory of relativity, the first whispers of quantum physics, Pluto represented humanity's expanding reach. The universe was no longer a fixed, completed structure. There were still frontiers left to cross, But the excitement wasn't just scientific. It was cultural. Pluto quickly captured the imagination of the public in ways few astronomical discoveries ever had. Newspapers featured artist depictions of the new planet as a ghostly blue sphere with swirling clouds and icy rings. Science fiction writers seized the opportunity. Pluto became a setting for alien civilizations, lost colonies, and interstellar mysteries. In popular magazines and pulp novels, Pluto was portrayed as a lonely outpost at the edge of existence, a world of eternal twilight and frozen deserts. Even popular culture embraced the name. In 1930, just months after the discovery, Walt Disney introduced a cheerful little dog named Pluto, supposedly in honor of the newly found planet. The coincidence helped cement Pluto's place in everyday life, a scientific discovery transformed into a household word. The public fell in love with the idea of the tiny ninth planet. It wasn't just a discovery anymore. It was a symbol of curiosity and wonder. However, as the years passed and technology improved, astronomers began to notice something strange. Pluto wasn't behaving like they expected a massive planet to behave. It was far too faint, and its gravitational pull on other bodies seemed almost non-existent. In fact, when compared to its brightness, Pluto appeared suspiciously small. Early size estimates began to shrink dramatically. In the 1940s, new calculations suggested that Pluto was smaller than Mars. By the 1950s, scientists realized it was likely smaller than Earth's moon. Still, the true nature of Pluto remained elusive. Its faint light made precise measurements nearly impossible. For decades, Pluto's actual size and mass were matters of speculation, often revised in textbooks every few years. But no matter how small the estimates became, Pluto retained its planetary status. People had grown attached to it. It was our ninth planet, and few were eager to give that up. One reason for this lingering assumption was emotional as much as scientific. To generations of students and astronomers, Pluto symbolized exploration itself, proof that there was more beyond the horizon. It had been found through persistence, patience, and the power of human intellect. To call it not a planet would have felt like an insult to that story. And so, even as the evidence for its small size mounted, Pluto held onto its title, at least for a while. Then in 1978, everything changed again. Astronomers James Christie and Robert Harrington at the U.S. Naval Observatory discovered that Pluto had a large moon, which they named Charon after the mythological ferryman of the dead. This discovery finally allowed scientists to measure Pluto's mass accurately for the first time, and the results were astonishing. Pluto was tiny. It had only 0.2% the mass of Earth and about 1/6 the mass of our moon. The great planet X that was supposed to be tugging on Neptune was far too small to have any such effect. The mathematical mystery Lowell had set out to solve decades earlier was still unsolved, and Pluto was no longer the answer. Yet instead of disappointment, the discovery of Charon only deepened Pluto's intrigue. The relationship between Pluto and its moon was unlike anything else in the solar system. Charon was so large, about half Pluto's diameter, that the two bodies actually orbited each other around a shared center of gravity located between them. In a sense, they formed a binary system, two worlds locked in a slow cosmic dance, facing each other eternally. For astronomers, this was a revelation. For the public, it was another reason to adore Pluto. A small world with an even smaller companion, both circling each other in the frozen dark. Through the mid-20th century, Pluto continued to fascinate astronomers and dreamers alike. With every new discovery, it seemed to grow more complex and mysterious. The more we learned, the more we realized how little we knew. Was it made mostly of rock or ice? Did it have an atmosphere? Could it even support some form of activity beneath its frozen surface? The answers would take decades more to uncover, but one thing was clear. Pluto was not just another rock drifting in space. It was a window into the past, a survivor from the early days of the solar system, preserved in the deep freeze of time. Even as doubts emerged about Pluto's planetary status, the public never wavered in their affection. To most people, Pluto wasn't defined by scientific classification. It was defined by its story. The young man who discovered it, the girl who named it, and the generations who grew up imagining it as a lonely but proud world at the solar system's edge. It had become part of our cosmic identity, proof that even in a vast and distant universe, we could still find and name the unknown. In those early decades after its discovery, Pluto represented both the power and the limits of human perception. From Earth, it was a faint dot of light, almost invisible, yet enough to change the way we saw the universe. We believed it was massive, important, and dominant. In truth, it was small, fragile, and overlooked. But that's what makes Pluto's story so profound. It mirrors the way science itself evolves. What we think we know often turns out to be only the beginning of understanding. Pluto's discovery was not just a new entry in astronomy textbooks. It was a chapter in the human story of curiosity. It reminded us that even the smallest flicker in the darkness might lead to something extraordinary. And though our assumptions about Pluto would later be challenged and eventually overturned, the thrill of its discovery marked a moment when the universe seemed larger, richer and more full of possibility than ever before. For most of the 20th century, what scientists and the public thought they knew about Pluto turned out to be wrong. Not because anyone was careless, but because the tiny world simply refused to reveal its secrets. Every telescope on Earth, even the largest ones of its day, showed Pluto as nothing more than a faint, flickering dot. From that dim speck, astronomers tried to guess its mass, its size, its color, and even what its surface might look like. They had to fill in the blanks with mathematics, imagination, and a fair amount of optimism. What emerged was a portrait of Pluto that was grand, romantic, and almost entirely inaccurate. When Pluto was first discovered, astronomers estimated it to be roughly the same size as Earth. This made sense at the time. If it truly were the long-sought Planet X, it needed enough gravity to tug on Neptune and Uranus. The earliest calculations gave it a mass several times greater than Earth's, a genuine giant lurking in the shadows. But those numbers weren't based on direct evidence. They came from the hope that Lowell's original prediction must have been correct. For decades afterward, Pluto was drawn on star charts as a substantial, solid planet, perhaps a cold twin of our own world, wrapped in frozen clouds and perpetual night. As better telescopes appeared, the myth began to crumble. In the 1940s, more careful brightness measurements suggested Pluto could not be that large. Its reflected light was too weak. By the 1950s, new analyses reduced its estimated mass again, this time to about that of Mars. By the 1960s, it had shrunk even further, to less than the Moon's. Yet textbooks and encyclopedias continued to call it a full-sized planet. Generations of students grew up imagining a frozen world, roughly Earth-sized, orbiting just beyond Neptune. It was easier to hold on to the familiar 9-planet model than to admit that the outermost member of the family might be tiny and strange. Part of the confusion came from Pluto's orbit, which was unlike any other planet's, while the others followed neat, nearly circular paths. Pluto's orbit was stretched into a long oval, tilted at a 17-degree angle to the rest of the solar system. For 20 years of each 248-year revolution, Pluto actually comes closer to the Sun than Neptune. Between 1979 and 1999, for instance, Pluto was officially the 8th planet from the Sun, not the 9th. This odd behavior puzzled astronomers for decades. Was Pluto being pulled by Neptune's gravity? Was its orbit evidence of yet another hidden world farther out? To the public, Pluto's unusual path only added to its mystique, a tiny rebel that refused to follow the rules. Even its appearance was misunderstood. For many years, Pluto was imagined as a smooth, featureless ball of ice, cold gray and dead. Artists painted it as a bluish or steel-colored orb, reflecting the idea that the farther you go from the Sun, the darker and more lifeless things must become. Nobody imagined the reddish tones that we now know are caused by complex organic molecules called tholins. Nor did anyone expect towering mountains of water ice or nitrogen glaciers that creep slowly across its surface. To most scientists before the 1980s, Pluto was little more than a frozen relic, inert, unchanging, and silent. Then, in 1978, the discovery of Charon, Pluto's massive moon, completely upended those assumptions. By studying Charon's orbit, astronomers could finally calculate Pluto's true mass, and the truth was shocking. Pluto was tiny, only 1/5 the diameter of Earth's moon, and less than 1,000th the mass of Earth. The numbers stripped away decades of illusion. The supposed Planet X could never have disturbed Neptune's orbit. The earlier gravitational anomalies were due to errors in measuring Neptune itself. The planet Lowell had spent his life searching for simply didn't exist. Pluto, it turned out, had been discovered by coincidence, a cosmic accident rather than mathematical destiny. Still, even with its newfound smallness, Pluto's reputation refused to shrink. Astronomers might have known it was diminutive, but to the public, Pluto remained the noble ninth planet, lonely, remote, and mysterious. Newspaper articles celebrated its peculiarity, a world smaller than our moon, yet still a proud member of the planetary family. It fit perfectly into the human narrative of the underdog, small but significant, fragile but enduring. When telescopes finally detected a faint atmosphere of nitrogen and methane in the 1980s, Pluto's status as a true world seemed secure again. Surely, they reasoned, if it had an atmosphere, it deserved to be a planet. Yet beneath the nostalgia, the scientific doubts continued to grow. Pluto's orbit crossed paths with a swarm of small icy bodies, an entire region of the solar system that astronomers were only beginning to recognize, the Kuiper Belt. The first hints of this vast collection of frozen remnants appeared in the early 1990s, and with each new discovery, Pluto looked less unique. One by one, astronomers found other objects almost its size, and one named Eris, that was even slightly larger. Suddenly, the story of Pluto changed from being the outermost planet to being one among many in a new, uncharted population. This realization forced scientists to confront an uncomfortable question: what exactly is a planet? For decades, the term had been used loosely. Any large body orbiting the Sun seemed to qualify. But if Pluto counted, shouldn't Eris, Haumea, and Makemake count too? Shouldn't the dozens, maybe hundreds, of similar worlds beyond Neptune also be called planets? If so, our tidy solar system of 9 planets could balloon into dozens. The very language of astronomy was on the verge of chaos. Even as scientists debated, popular culture clung fiercely to the old idea. Pluto wasn't just a data point, it was ours. Its demotion, when it finally came in 2006, would spark outrage precisely because of these early misconceptions. For more than 70 years, people had imagined Pluto as something it never truly was, a full-fledged planet with the same dignity as Earth or Jupiter. In a way, we had grown emotionally attached to a scientific mistake. Those misconceptions, however, weren't meaningless. They show how science evolves. Each assumption, each correction, brought us closer to the truth. From an imagined giant to a tiny frozen world. From a solitary planet to a member of a bustling Kuiper Belt. From a mathematical mystery to a symbol of scientific humility, Pluto's story mirrors the way knowledge itself grows. Through error, revision, and rediscovery. What we got wrong about Pluto wasn't just its size or its orbit. We got wrong the very idea that understanding the universe is ever complete. Pluto's shifting identity, planet, dwarf planet, or something else entirely, reminds us that science is not static. It is a living process, always changing as our tools sharpen and our minds open. And so, while early astronomers misjudged Pluto's scale and nature, they also did something profoundly right. They looked outward, beyond what they could see, and dared to imagine a world waiting in the dark. That act of curiosity, more than any label, is what defines Pluto's true legacy. For more than 70 years, Pluto had reigned quietly at the edge of our solar system, small, distant, and beloved. From classroom posters to space documentaries, it was always there, the 9th planet, the tiny ice world orbiting in the farthest reaches of sunlight. Children memorized its name alongside Mercury, Venus, Earth, and the rest. It was part of our cosmic family, a symbol that even the smallest world could matter. But in 2006, everything changed. Pluto's title as the 9th planet was stripped away in one of the most controversial decisions in the history of science. The roots of that decision go back to the early 1990s, when astronomers began to find other icy bodies orbiting beyond Neptune. For decades, Pluto had been considered a unique loner, the only known world in its distant region. But as new telescopes and digital detectors became more powerful, they began revealing a hidden population of small, frozen objects, chunks of rock and ice orbiting the Sun in a vast ring now known as the Kuiper Belt. At first, these discoveries seemed minor, small, faint, and insignificant. But they kept coming. By the late 1990s, Astronomers had catalogued dozens of them and soon hundreds more. Some were just a few hundred kilometers across. Others rivaled Pluto in size. The deeper scientists looked, the clearer it became. Pluto wasn't alone at all. It was just the brightest and closest member of a much larger family. A family that stretched billions of kilometers beyond Neptune. Then, in 2005, astronomer Mike Brown and his team at Caltech announced something that changed everything. They had discovered a new object, slightly larger than Pluto, orbiting even farther away. It was named Eris after the Greek goddess of discord and strife, a name that would prove eerily prophetic. The discovery of Eris forced astronomers to confront a question they had long avoided. If Pluto was a planet, what was Eris? And if Eris was a planet, how many more would we soon have to add? Eris wasn't unique either. By then, other bodies like Haumea and Makemake had also been found, each with their own moons and unusual orbits. The solar system was suddenly looking crowded, and the old definition of a planet, which dated back centuries, no longer seemed to fit. Astronomers realized they needed a clear, universal definition of what exactly made a planet a planet. The debate began quietly at first, in scientific journals, at conferences, in observatories around the world. But as the argument grew, it spilled into the public eye. Could Pluto really be downgraded? The idea seemed almost heretical. Newspapers ran headlines like, "Is Pluto doomed?" and scientists to vote on the fate of the 9th planet. Teachers wondered what to tell their students. Late-night comedians joked that Pluto had been fired. What had started as a technical discussion among astronomers had turned into a global, emotional event. In August 2006, the International Astronomical Union, IAU, the organization responsible for naming and classifying celestial bodies, gathered in Prague to settle the matter once and for all. Hundreds of astronomers from around the world attended. Their task, to create an official definition of the word planet. But what seemed simple turned out to be one of the most divisive debates in modern science. For days, committees argued, voted, and revised proposals. Some astronomers argued that size should be the defining factor. If an object was big enough to be rounded by its own gravity, it should count as a planet. By that logic, Pluto and even Eris would qualify. Others said a planet must not only be round, but also dominate its orbit, clearing away other debris with its gravity. That second rule, the idea of clearing its neighborhood, became the turning point. On August 24, 2006, the IAU adopted a new definition. To be called a planet, an object must meet 3 criteria. It must orbit the Sun. It must be massive enough for its own gravity to pull it into a nearly round shape. It must have cleared its orbit of other debris. Pluto passed the first 2 tests easily. It orbits the Sun and it's round, but it failed the third. Its orbit is messy, shared with many other icy bodies in the Kuiper belt. In fact, its path overlaps with Neptune's. By the new rules, Pluto no longer qualified. It was reclassified as a dwarf planet. The announcement sent shockwaves around the world. For many people, it felt like losing an old friend. Newspapers mourned, classrooms scrambled to update charts, and debates erupted on talk shows and online forums. Children wrote letters begging astronomers to bring Pluto back. Protesters even gathered outside planetariums, holding signs that read, "Pluto is still a planet in my heart." The story wasn't just about science anymore. It was about identity, nostalgia, and the human tendency to grow attached to what we once believed. Even among scientists, the decision was far from unanimous. Only a small fraction of the IAU's 9,000 members were present for the final vote, just a few hundred people. Many astronomers argued later that the definition was flawed, arbitrary, and overly simplistic. Why should an object's ability to clear its neighborhood matter more than its composition or history? Others pointed out that Earth itself shares space with asteroids and debris, so technically, even our planet hasn't cleared its orbit completely. The debate, far from ending, only deepened. Meanwhile, Mike Brown, the discoverer of Eris, embraced his unintended role as the man who killed Pluto. He argued that the change was necessary, that it made sense to group Pluto with the other small icy worlds of the Kuiper belt, rather than force it to fit an outdated model. In his view, Pluto hadn't been demoted. Science had simply evolved. But not everyone agreed. Some astronomers, like Alan Stern, the principal investigator of NASA's New Horizons mission, fiercely defended Pluto's status. Stern argued that the IAU's definition was flawed because it only applied to objects orbiting the Sun. By that logic, planets around other stars weren't even planets at all. To Stern and many others, Pluto remained a planet, not because of nostalgia, but because of its complexity. It had moons, weather, a layered atmosphere, and geological activity. It was more dynamic than even some of the larger planets. If you flew past it, Stern once said, you wouldn't think you were looking at anything less than a planet. The controversy never really faded. In the years following 2006, countless polls showed that the public still considered Pluto a planet. Planetariums continued to include it in exhibits. Teachers found creative ways to explain the redefinition without disappointing their students. It's not gone, they would say. It's just in a new category. In truth, Pluto's demotion might have broken our hearts, but it also deepened our fascination with it. Ironically, just when Pluto seemed most diminished, it was about to shine brighter than ever. In 2015, NASA's New Horizons spacecraft made a historic flyby, giving humanity its first ever close-up images of Pluto's surface. What it revealed stunned the world. Vast plains of nitrogen ice, mountain ranges of frozen water, and evidence of active geology. Far from being a dead rock, Pluto was alive with motion, texture, and mystery. The little world that had been cast out of the planet family turned out to be one of the most fascinating places we'd ever seen. In that moment, something beautiful happened. The argument about labels began to fade, replaced by awe. Pluto didn't need a title to matter. Whether planet or dwarf planet, it was still a world, ancient, active, and full of surprises. The controversy of 2006 had forced us to rethink what a planet really is, but it also reminded us of something deeper. Our definitions may change, but our wonder never does. Today, nearly 2 decades after that vote in Prague, the debate still flickers among astronomers and dreamers alike. Some advocate for restoring Pluto's planetary status. Others propose expanding the definition to include dozens more worlds. But perhaps the real lesson lies not in how we categorize Pluto, but in how its story mirrors our own. Science, like Pluto, evolves and it wanders, it redefines itself, and it never stops moving forward. And so, while Pluto may no longer hold the title of the 9th planet, it holds something far greater, a legacy that reminds us that even the smallest, most distant worlds can challenge everything we thought we knew and inspire us to keep exploring. For decades, Pluto was little more than a faint point of light on astronomers' charts, mysterious, blurry, and impossibly distant. Even with the most powerful telescopes on Earth, it appeared as a smudge of pixels, its surface features hidden behind nearly 5 billion kilometers of space. To scientists and dreamers alike, Pluto remained an enigma. What did this tiny frozen world actually look like? Was it just a dull, cratered ice ball, or was there something more waiting to be discovered in the dark? Those questions lingered unanswered for generations. But in January 2006, just months before Pluto was officially demoted from planet status, NASA launched a spacecraft that would change everything. Its name was New Horizons, a name that perfectly captured its mission, to push beyond the limits of what humanity had ever seen before. New Horizons was a small spacecraft, no bigger than a baby grand piano, but it carried with it one of the most ambitious missions in the history of space exploration, a 3 billion-mile journey to Pluto. It would be the fastest spacecraft ever launched, leaving Earth at over 58,000 kilometers per hour. Even at that incredible speed, the trip would take nearly 9.5 years. By the time New Horizons reached Pluto, it would have traveled longer and farther than any mission in human history to visit a new world. As it hurtled through space, New Horizons went into hibernation for much of its journey, occasionally waking up to check its systems and recalibrate its instruments. It flew past Jupiter in 2007, using the giant planet's immense gravity to slingshot itself even faster toward the outer solar system. From that point on, it cruised silently through the deep cold, carrying with it not just cameras and sensors, but the hopes of millions who still looked to Pluto with fascination. Meanwhile, on Earth, the debate over Pluto's status raged on. By the time New Horizons was halfway there, Pluto had already been reclassified as a dwarf planet. but the mission team refused to see it as anything less than extraordinary. They often joked that while bureaucrats on Earth could change Pluto's title, they couldn't change what the spacecraft would find. They knew that once humanity finally saw Pluto up close, it would never again seem small or insignificant. As New Horizons approached its destination in mid-2015, anticipation built to a fever pitch. The world watched as the first distant images began to trickle back. At first they were fuzzy, just a few blurry pixels, but as the spacecraft drew nearer, those pixels began to take shape. A reddish tint appeared, hinting at complex chemistry on Pluto's surface. Then, as more images came in, something unexpected came into focus. A bright heart-shaped region stretching across the planet's face. That simple image changed everything. The heart of Pluto, as the public called it, instantly became a global symbol of wonder and affection. It was as if the tiny world at the edge of our solar system was sending a message, not of bitterness over its demotion, but of quiet pride. It seemed to say, "You may have forgotten me, but I'm still here." Then, on July 14, 2015, after traveling more than 4.8 billion kilometers, New Horizons made its historic closest approach to Pluto, just 12,500 kilometers above the surface. In a span of hours, it captured data that would take months to transmit back to Earth, as radio signals took more than 4.5 hours to travel each way. What the spacecraft revealed stunned scientists and the public alike. Far from being a dead, frozen relic, Pluto turned out to be alive with activity. A dynamic, geologically complex world, unlike anything anyone had expected. Its surface was a mosaic of terrains, towering mountains made of water ice, vast plains of frozen nitrogen, and mysterious dark regions whose composition was still unknown. The heart-shaped region, officially named Tombaugh Regio in honor of Pluto's discoverer, was made of nitrogen and carbon monoxide ice, with textures suggesting glacial flow. At the western lobe of the heart lay a vast plain known as Sputnik Planitia, an immense, icy basin roughly the size of Texas. To scientists' astonishment, the plain was smooth, with almost no visible craters, a sign that it was geologically young, possibly still being reshaped by internal processes. Somehow Pluto, a body smaller than our moon, was showing signs of ongoing geological activity. It was not a dead world frozen in time. It was evolving, shifting, breathing in its own strange way. Even more astonishing was the evidence of atmospheric layers and haze. As New Horizons passed behind Pluto, sunlight filtering through its thin atmosphere revealed multiple layers of blue haze stretching high above the surface. The images were hauntingly beautiful, delicate and ethereal, glowing against the blackness of space. It was proof that Pluto wasn't just a rock. It had weather, atmosphere, and perhaps even a cycle of nitrogen that waxed and waned with its 248-year orbit around the Sun. Scientists also discovered that Pluto's surface color, that distinctive reddish-brown hue, came from complex organic molecules known as tholins, created when sunlight interacts with methane in the atmosphere. Over time, these molecules settle onto the surface, tinting it with shades of red, orange, and brown. The same chemistry that gives Titan, Saturn's moon, its golden haze was happening on Pluto, 5 billion kilometers away. Pluto's moons also revealed their secrets. The largest, Charon, was no ordinary satellite. With a diameter half that of Pluto, it was massive enough that the two worlds actually orbit each other around a shared center of gravity, a cosmic dance frozen in time. Charon's surface bore deep canyons and cliffs, some stretching farther than the Grand Canyon, suggesting that it too had once been geologically active. The smaller moons, Nix, Hydra, Kerberos, and Styx, spun chaotically like tumbling dice, caught in the gravitational tug of Pluto and Charon's mutual orbit. Every new image challenged old assumptions. The world once dismissed as too small and too cold for anything interesting turned out to be one of the most complex and beautiful places ever visited. Pluto had mountains, plains, glaciers, haze, and perhaps even hints of an underground ocean beneath its icy crust. It was, in every sense of the word, a world, alive, evolving, and intricate beyond imagination. For the scientists of the New Horizons mission, it was vindication. Many of them had spent their entire careers working toward this single encounter, knowing that once the spacecraft flew past Pluto, there would be no second chance. The data it collected would be all humanity would have for decades to come. And it was perfect, better than anyone dared hope. When the first full-color images were released to the public, they captured the world's imagination. People who had grown up mourning Pluto's demotion now saw it in a new light, not as a lost planet but as a wonder in its own right. Social media exploded with images of the heart of Pluto. Scientists gave emotional press conferences, and for a brief moment, the entire world looked outward together, united by awe. In a poetic twist of fate, the very spacecraft launched when Pluto was still officially a planet had arrived just in time to show that titles didn't matter. Pluto's beauty spoke for itself. It didn't need to be a planet to inspire. It was a frontier, a frozen world that defied expectations and reminded us why we explore in the first place. The New Horizons mission didn't just give us pictures, it gave Pluto back its dignity. It reminded the world that exploration is not about labels, but about discovery, about daring to look beyond the known and finding wonder where others see emptiness. Today, years after that flyby, the images of Pluto still resonate. The blue haze, the icy heart, the endless plains of frozen nitrogen. They tell a story that no scientific debate could erase, that even in the coldest, most distant corners of our solar system, there is beauty, complexity, and life's quiet echo in the form of geological motion and chemical change. Pluto, once thought to be an insignificant outcast, had the last word, revealing a world far richer than anyone ever imagined. In that moment, it stopped being the planet that was lost and became something far greater, the world that reminded humanity to never stop seeking, never stop questioning, and never stop believing that even the smallest places can hold the biggest surprises. When the first high-resolution images of Pluto came streaming back from New Horizons, the world stood in collective wonder. That distant speck of light, once dismissed as a frozen relic, had revealed itself as a living, dynamic world. But beyond its icy mountains and heart-shaped plains, Pluto's greatest gift wasn't its scenery. It was perspective. Pluto changed how we see the solar system, how we define worlds, and even how we think about our own place in the cosmos. For over 70 years, the solar system was taught as a simple, orderly chain. The rocky inner planets, the gas giants, and then the lonely Pluto. Small and far away, but that view was a simplification, a tidy map drawn by the limits of our imagination. What Pluto and the discoveries that followed showed us was that the solar system isn't a neat family of 9 planets. It's a vast, complex ecosystem of objects, worlds, dwarf planets, asteroids, comets, and countless icy bodies, all remnants of the same ancient material that once formed our Sun and Earth. Before Pluto's discovery, astronomers thought the edge of the solar system was empty. Now we know it's teeming with worlds, thousands of icy objects forming the Kuiper Belt, stretching billions of kilometers beyond Neptune. Now, these aren't just random leftovers, they're the building blocks of planets, time capsules from the earliest days of our solar system. Each one holds chemical clues about how the planets, and maybe even life itself, began. Pluto, in many ways, became our gateway to the Kuiper Belt. Before its discovery, we didn't even know that region existed. But once we found Pluto and began to explore it, we realized it was part of a much bigger story, one that connects to the very origins of the solar system. By studying Pluto's icy surface, scientists gained insight into how volatile materials like nitrogen, methane, and carbon monoxide behave in extreme cold, the same materials that may have shaped the early atmospheres of Earth and other planets. Even more fascinating, Pluto revealed that small worlds can be just as complex as large ones. Traditionally, astronomers assumed that geological activity required size, a planet big enough to retain internal heat. But Pluto defied that logic. Despite being smaller than our moon, it showed evidence of glaciers, convection cells, and possible cryovolcanoes, icy volcanoes that erupt not with lava, but with frozen gases. Something inside Pluto was still generating enough energy to reshape its surface. That discovery changed how scientists think about planetary evolution. It suggested that even tiny frozen worlds could remain active for billions of years, powered not by sunlight, but by radioactive decay or hidden oceans beneath the ice. It made astronomers wonder, If Pluto could do this, what about other icy bodies farther out, like Eris, Haumea, or Triton, Neptune's captured moon? Could the outer solar system be far more dynamic than we ever imagined? The more we learned, the more we realized that Pluto isn't an oddball, it's a prototype. It represents an entire class of objects that hold the key to understanding how our solar system formed. The Kuiper Belt, once invisible to us, turned out to be a frozen archive of our cosmic past, a library written in ice, with Pluto as its most eloquent chapter. Pluto also forced scientists to confront deeper questions, not just about space, but about the language of discovery itself. What makes a world a planet? Is it size, shape, orbit, or something more intangible? A sense of identity, of belonging to the story of our solar system. The 2006 redefinition that demoted Pluto didn't just change a label. It sparked a philosophical debate about what discovery really means. In a way, Pluto became a mirror, reflecting our human need to classify, to name, to make sense of chaos. But it also reminded us that science isn't static. It's not about drawing permanent boundaries. It's about expanding them. When we changed the definition of a planet, we didn't diminish Pluto. We expanded the solar system. We went from 9 planets to a universe full of worlds waiting to be understood. That shift has profound implications for how we view exoplanets, worlds beyond our sun. Before Pluto, we assumed that our solar system was typical, that every system would have a few large planets orbiting neatly around their star. But the truth, as revealed by thousands of exoplanet discoveries, is far more chaotic and diverse. Some systems have planets larger than Jupiter, orbiting closer than Mercury. Others have icy mini-worlds scattered like confetti. Pluto's story taught us to expect the unexpected, to see variety, not uniformity, as the rule of the universe. Culturally, too, Pluto left a deep mark. It became a symbol of humility, a reminder that even when our ideas are proven wrong, that's not a failure of science, but its greatest strength. When astronomers reclassified Pluto, they didn't erase it from history. They showed the world that truth evolves. Science is not about holding on to comforting stories, but about rewriting them when new evidence demands it. Yet for all the technical debates, Pluto never lost its emotional pull. It remains one of the most beloved objects in the sky, not because of its classification, but because of its story. The story of a tiny world that captured our hearts was cast out, and then against all odds returned to astonish us. It's the story of curiosity triumphing over certainty, of exploration over ego. For the scientist who worked on the New Horizons mission, that's Pluto's true legacy. It's not about whether it's a planet or a dwarf planet. It's about what it represents, the spirit of discovery. When the spacecraft flew past Pluto, it became the first to explore a world beyond Neptune. That single moment symbolized the best of what humanity can do: build, explore, question, and reach across unimaginable distances to touch the unknown. And in doing so, Pluto reminded us of something profound, that there is no edge to discovery. Every time we think we've reached the limits of our knowledge, the universe gently proves us wrong. The solar system didn't end with Neptune, and understanding didn't end with Pluto's demotion. In fact, that's where a whole new story began, one of countless frozen worlds, ancient secrets and endless horizons still waiting to be explored. In the end, Pluto's greatest lesson is not about what it is, but about what it means to seek. It taught us that curiosity is more powerful than certainty, that wonder is greater than labels, and that even in the coldest reaches of the cosmos, there are hearts, icy or otherwise, still beating with the pulse of creation. There's something deeply human about Pluto. Maybe it's the way it sits out there, small, cold, and distant, circling the sun on its lonely, tilted path. Or maybe it's because, in a way, Pluto's story mirrors our own. Misunderstood, overlooked, and yet still quietly beautiful, still full of wonder. When Pluto was first discovered in 1930, the world fell in love with it instantly. Newspapers hailed it as the 9th planet, the long-sought mystery world at the edge of the solar system. For generations of children, Pluto was part of the family, the final piece in every classroom's solar system model, the dot that completed the dance of planets around the sun. It was comforting, somehow, to know that even at the farthest reaches of our cosmic home, there was still something waiting, something ours. But in 2006, when the International Astronomical Union declared that Pluto was no longer a planet, something unexpected happened. People didn't just shrug and move on, they got angry. Letters poured in from students, teachers, and ordinary citizens. Late-night hosts joked about justice for Pluto. Astronomers found themselves explaining to tearful kids why their favorite planet had been taken away. Why did people care so much about a ball of ice billions of miles away? Because Pluto wasn't just a planet. It was a symbol of curiosity, of imagination, of the joy of discovery itself. When it was stripped of its planetary title, it had felt like something innocent had been lost. Children had memorized the phrase, "My very educated mother just served us 9 pizzas." Without Pluto, the pizzas disappeared. Adults felt nostalgic for the simplicity of the universe they'd grown up learning about, a universe that felt whole. And deep down, many saw a reflection of themselves in Pluto, small, overlooked, yet still part of something vast and magnificent. The backlash wasn't just about science, it was about belonging. Pluto's story became a metaphor for underdogs, for outsiders, for anyone who's ever been underestimated or told they didn't quite fit the definition. When Pluto was demoted, it didn't fall from grace. Instead, it rose as a cultural icon, a kind of celestial rebel who refused to be defined by rules written far away. You could see it everywhere. In comics, Pluto was drawn wearing sunglasses, holding a protest sign that read, "Still a planet in my heart." In classrooms, teachers used the debate to remind students that science changes, that knowledge evolves, and that that's something to celebrate, not fear. And when NASA's New Horizons spacecraft sent back that first image, that radiant heart-shaped plane shining from the surface, the internet exploded. It was as if Pluto had sent a message across the void. "See? I still matter." That heart became a symbol, not of defiance, but of warmth. Pluto, the farthest and coldest of them all, had the biggest heart. It didn't seek revenge for its reclassification. It simply showed us who it really was, stunning, complex, alive with mystery. People everywhere felt something stir inside them. The world fell in love all over again, not with a planet, but with a story. Pluto reminded us that science is not just a collection of facts. It's a human journey. It's filled with emotion, hope, and sometimes heartbreak. When we explore, we're not just charting the universe, we're revealing pieces of ourselves. And Pluto, with all its contradictions, became a mirror for that truth. Even today, when people look up at the night sky and think of Pluto, there's a certain tenderness there. Astronomers see a world rich in data, but ordinary people see something else, a little world that refused to fade away. Pluto's distance, its smallness, its isolation, those are the very things that make it feel so alive to us. Because in its story, we see the essence of what it means to be human, to reach out, to be curious, to fight for meaning in an endless expanse. Every image that came from New Horizons, every icy mountain, every smooth nitrogen plane felt like a message of endurance. Pluto was saying, "You can strip away my title, but not my story." And that's why, years after the debates have quieted, Pluto still lives in the collective imagination. It's on posters, in children's books, in songs, and in the quiet dreams of those who look up at the night sky and wonder what's still waiting to be found. In a world that often measures worth by size, speed or power, Pluto teaches something radically different. It shows that greatness isn't about being the biggest or the brightest. It's about resilience, mystery, and the ability to capture hearts despite the odds. Pluto doesn't orbit neatly with the others. It carves its own eccentric path through space, and maybe that's what makes it so beloved. It reminds us that even if we don't fit the mold, we can still belong, just in our own way, on our own terms. Pluto may not be a planet anymore, but in the story of humanity's quest to understand the cosmos, it's something even more timeless, a symbol of curiosity, humility, and hope. It stands as a tiny, frozen reminder that even at the farthest edge of our solar system, love, in all its quiet, enduring forms, still finds a way to shine. The story of Pluto doesn't end with a single flyby. In fact, that moment, when New Horizons sailed past Pluto in July 2015, was not the end of a journey, but the beginning of a far greater one. It opened a door to a part of our solar system that had never been seen, never touched, never even imagined in its true complexity. When New Horizons left Pluto behind, it didn't stop exploring. Its mission team, still hungry for discovery, aimed the spacecraft even deeper into the dark. Ahead lay a vast and mysterious region, the Kuiper Belt, a frozen frontier filled with remnants from the dawn of the solar system. These were worlds that had never been shaped by heat or gravity the way Earth was. They were time capsules, perfectly preserved fragments of the ancient disk of dust and gas that once circled the newborn sun. For decades, the Kuiper Belt had been a theory, a mathematical prediction whispered in astronomy textbooks, but now with Pluto as our guide, it was becoming a real physical place. Each icy body drifting in that shadowy region held a piece of the puzzle, a clue to how the solar system was built, and perhaps even how life's raw materials first came together. Just months after the Pluto encounter, NASA identified a new target, a tiny distant object called Arakoth, originally nicknamed Ultima Thule. It lay over 1 billion miles beyond Pluto, in the deepest regions of the Kuiper Belt. Reaching it would be like shooting an arrow across a vast ocean to hit a pebble floating in the dark. And yet, in 2019, New Horizons did exactly that. When the first images arrived, they stunned the scientific world. Arakoth looked like two snowballs gently fused together, a contact binary, shaped not by violent collisions, but by slow, graceful motion in the earliest days of the solar system. Its surface was smooth and untouched, painted in soft red tones, a witness to 4.5 billion years of cosmic history. That single encounter answered one of science's oldest questions. How did planets begin to form? The evidence from Arakoth suggested that the building blocks of worlds didn't crash together in chaos, but merged peacefully, like dust drifting into clouds, bonding under gravity's tender pull. It was a revelation, one that changed our understanding of planetary birth. But the discoveries didn't stop there. The deeper New Horizons traveled, the clearer it became that Pluto was not a lonely outpost. It was the first of many, the brightest beacon in a vast population of hidden worlds. Objects like Eris, Haumea, and Makemake began to reveal themselves through powerful telescopes, each one with its own quirks, spinning ellipsoids, ring systems, strange compositions. The outer solar system was no longer a void. It was an archipelago of frozen secrets, and somewhere beyond even the Kuiper Belt lies another mystery, a gravitational whisper in the dark that astronomers call Planet 9. If it exists, it's far larger than Earth, orbiting the Sun at a distance so immense that a single year there might last tens of thousands of hours. Its presence is hinted at by the strange clustering of distant orbits, objects tilted and stretched in ways that defy simple explanation. The search for Planet 9 is, in many ways, a continuation of the same story that led to Pluto's discovery a century ago. The human drive to look for what's hidden, to chase the faintest signals in the cosmic noise, to keep asking questions, even when the answers seem impossibly far away. And that's the heart of it, the unbroken chain of curiosity that links Lowell's dusty observatory to Clyde Tombaugh's blink comparator, and onward to the digital instruments of New Horizons gliding silently through space. Each generation passes the torch of exploration to the next, proving that discovery is not a moment. It's a continuum. As New Horizons continues its journey, still speeding through the Kuiper Belt, still sending data back across the void, it serves as a living symbol of human persistence. It's a small machine powered by plutonium and hope, carrying messages from a civilization that refuses to stop wondering. Even now, billions of kilometers from home, it continues to scan the horizon, searching for new worlds, and somewhere out there beyond the range of its instruments, the edge of our solar system slowly gives way to the interstellar medium, the thin, invisible boundary between our sun's domain and the galaxy beyond. Someday another spacecraft will cross that threshold. Someday humanity will follow. But Pluto, quiet, distant Pluto, will always mark the turning point, the moment we realized that the edge of the map was not the end, but an invitation, because in the grand story of the cosmos, every end is only the start of another journey. The demotion, the flyby, the discoveries beyond, all of it is part of the same narrative, our endless desire to explore, to learn, to reach. Pluto taught us that the universe is not something to be conquered or categorized, but something to be understood. And that understanding begins with wonder. Maybe that's why we can't let go of Pluto. It's not just a world. It's an idea, a reminder that even the smallest things can change how we see everything else. When we look at Pluto, we're not just seeing ice and rock. We're seeing our own reflection, a species that dares to dream beyond its boundaries, to keep searching, even when the light grows dim. And as New Horizons sails onward into the unknown, its signal fading a little more with each passing year, it carries with it a simple truth, one whispered across billions of miles of empty space. The universe is vast, but the human spirit is vaster still. At the edge of the solar system, where sunlight fades into eternal twilight, there drifts a small frozen world. It's easy to overlook it, a faint glimmer in a sea of stars, a tiny traveler circling the sun in slow, patient silence. But that little world, Pluto, has done something extraordinary. It has changed how we see the universe, and how we see ourselves. For nearly a century, Pluto has been more than a planet, more than a collection of ice and rock. It has been a story about curiosity, resilience, and the unending human hunger to explore. From the moment Clyde Tombaugh spotted that faint dot of light in 1930, Pluto became a symbol of discovery, proof that even from a small observatory in Kansas, one person's determination could expand the boundaries of human knowledge. And when we sent New Horizons racing across the void to meet it, we carried that same spirit, the same hope that drives every generation to look up and ask, what's out there? When that spacecraft reached Pluto after 9.5 years of travel, what it found wasn't just a world, it was a revelation. Icy mountains, flowing glaciers, a glowing blue atmosphere, and a heart-shaped plain. It was beautiful, alive, and breathtakingly complex. For a moment, the world paused, united not by politics or language or borders, but by wonder. It reminded us that even in the coldest, darkest corners of space, there is beauty waiting to be seen, beauty that asks for nothing more than a curious eye and the courage to go looking. Pluto's story also taught us something humbling, that knowledge is never fixed. We once thought we understood our solar system perfectly, 9 planets neat and complete. But Pluto reminded us that the universe doesn't fit inside our definitions. When astronomers reclassified it as a dwarf planet, they weren't diminishing it, they were expanding our understanding. They showed us that science is not a set of answers, but a living, evolving conversation. In that moment, Pluto stopped being just a planet. It became something more timeless and a symbol of growth. It taught us that being wrong is not failure. It's how discovery moves forward, and perhaps that's why Pluto resonates so deeply with us. Because its story mirrors our own. We've all had moments when we felt small or forgotten, when the world seemed to say we didn't belong. But Pluto shows that even at the edge of everything there is purpose, that even the smallest voice can echo across the cosmos. In its icy silence, Pluto tells a profoundly human story, of endurance, of identity, and of finding beauty in solitude. It reminds us that being distant doesn't mean being disconnected, that even the coldest worlds can hold warmth, and even the faintest hearts can shine with meaning. As New Horizons continues to drift through the Kuiper Belt, sending its whispers of data back to Earth, it carries not just measurements and numbers, but a message from a world that refused to be forgotten. It tells us, keep going, keep asking, keep wondering, because the true frontier isn't Pluto, it's the spirit that sent us there. It's the restless curiosity that drives us to look beyond what we know, to imagine worlds we've never seen, to explore not just the stars above us, but the questions within us. Maybe one day, long after New Horizons falls silent and drifts into the interstellar night, another generation will look out from a distant world and remember Pluto, the little planet that wasn't a planet, but became so much more. They'll remember that curiosity can travel farther than any spacecraft, that imagination can bridge any distance, and that even in a universe so vast, we are never truly alone. Because when we explore, when we reach for the unknown, we are touching something eternal, the same spark that first lit the stars, the same flame that burns quietly within us all. Pluto taught us that exploration isn't about size or distance or even discovery. It's about connection, about the bond between a small blue world and the tiny hearts that dare to look beyond it. And as we look up at the night sky, where that faint little dot still circles in its slow, endless orbit, we can smile, knowing that somewhere out there, 5 billion kilometers away, a heart still shines on Pluto's surface. A heart that reminds us that the universe is vast, mysterious, and endlessly beautiful. And that humanity, fragile, curious, and unyielding, will always find a way to reach for it. Out there, beyond the warmth of the sun, beyond the last trails of light that reach our eyes, Pluto continues its lonely dance through the dark. It takes 248 years to complete a single orbit, a journey so long that not one human being has ever seen it make the full trip. And yet it keeps moving, steady, faithful, unbroken. Every second, its heart-shaped plane catches faint sunlight, glowing softly against the black. That light travels for 5 hours before it ever reaches us, but it does reach us. And in that faint, delayed shimmer is a message, one that speaks to who we are. We are a species that builds telescopes to see the invisible, that sends machines across billions of miles just to understand a world we'll never touch. We do this not because it's easy, but because something deep inside us whispers that knowing is beautiful, that the unknown is not something to fear, but something to love. Pluto will always be more than a dwarf planet. It's a promise that no matter how small we feel, no matter how far we wander, there will always be new horizons waiting to be reached. So when you look up tonight, find that dim corner of the sky where the sun fades into forever. Somewhere in that darkness, a tiny world still circles, cold, distant, and glowing faintly, with the reflection of our curiosity. And if you listen closely, you might just hear it whisper back, "Keep going. There's always more to discover."